Hello, Honors Algebra 2. We're going to talk about the Eqns section 9.2 called Solving Exponential Equations by Rewriting the Base. Our objective is to solve exponential equations by rewriting the base. Pretty straightforward. So let's take a look at our first problem, our first two problems, actually. And so let's divide this, and let's look at problem A. We've got 4 to the 3x equals 4 to the second. So this is the most basic problem, and what's important are that the bases are the same. As long as the bases are the same, I can ignore them and set the exponents equal to each other. So what I want to do is I want to have a 4 there and I want to have a 4 there. I do not want to do that problem. I don't want to simplify that. I want it to stay there so that I can write this problem. Then I just solve for x. I'm doing 3 times x. I need to get the x by itself, so I'm doing multiplication. To get rid of that 3, I need to do division. So 3 over 3 is 1. 1 times x is x, and 2 over 3 doesn't reduce, doesn't simplify, so I just get x equals 2 over 3. All right, let's look at part B. Again, I've got a 6 there and a 6 there, so I can ignore them and just set the exponents equal to each other. All right? And we could do this either way. The most important part of this right now, you might remember from other algebra problems, is make sure you got all the x's on the same side first. So I think I'm going to look at this minus 2x, this negative 2x, and add 2x to both sides. That'll give me 4x minus 3 equals, this makes 0, so 0 plus 1 is just 1. And then I've got minus 3, so I'll do plus 3 on both sides. Always working towards getting the x by itself, and you always use good rule of thumb, get rid of the things farther away that are on the same side of the equal sign. So this is 4x plus 0, negative 3 plus 3 is 0, is 4x equals 1 plus 3 is 4, and then I can divide by 4, and have x equals 1. All right, I'll give you a moment to look at that. And let's move on to the next problem. All right, so now we don't have the same bases. In fact, we've got a number and then a base and an exponent. So what you're hoping for in these situations is that you can take this and have it be a power of 5. Well, to do that, you want to break it down. We'll do a factor tree. I know it divides by 5. If I do 3,125 divided by 5, I get what? I get 6. Okay, the one will be 4. 641. No, that's not right. Let me do this a little more carefully then. 3,125 divided by 5 is 6. That's 30. Subtract, give me 1. Bring down the 2, give me 12. 2, which is 10. It's 25. 625. There we go. And then if you do divide by 5 again, there, that'll be 1, 2, and 5. And divide by 5 again, and that'll be 25, and that's 5 times 5. So we've got 1, 2, 3, 4, 5 of them, so this is 5 to the 5th equals 5 to the negative 10 plus 3. 3x. And now I can ignore the bases and set the exponents equal to each other and solve. Easiest way to solve is to get rid of things on that side, add 10 to both sides, have 15 equals 3x, get rid of the 3 by dividing, and have 5 equals x. All right, I'll give you a chance to look at that for a moment. And let's go on to our next problem. Now we've got two things with bases, but they're different bases. And the thing that you would hope for is that you could take the larger one and call it a power of the smaller one, like we did in the last one. We turned that big number into a power of 5. However, if you do 49 times 49, it turns out to be way bigger than 343. You can check that on a calculator. So the next thing is you hope that you can turn both of them into a power of a lower number. For instance, I know that 7 to the second is 49. So I might want to check 7 to the third. Well, that's 49 times 7, right? That's 7 3 times. 49 is the first 2 times that you multiply 7, and then you got to do it again. So let's check 49 times 7. 7 times 9 is 63. Carry the 6. 7 times 4 is 28. 28 and 6 is 34. 343. So, instead of writing 49 here, I could write it as 7 squared to the 3x equals, and instead of writing 343, I could write that as 7 cubed raised to the 2x plus 1. Then you have to use your exponent rules. And my exponent rules say that when I raise a power to another power, as I'm doing there and there, I multiply those two things. So this is 7 to the 2 times 3x equals 7 to the 3 times all of this, 2x plus 1. So as you can see, this one here we're going to have to distribute. So this is going to be 7 to the 6x equals 7 to the 6x plus 3. Okay. And then I can ignore the bases and see what I have. So now we're going to run into a weird thing, right? Because I'm going to subtract 6x on both sides, and I'm going to get 0 equals 3. But that's clearly not true, right? So what that means is that there is no x that I could ever plug in that would work for this. So because I have a contradiction, that is the symbol for contradiction, I get an answer of no solution. And sometimes those happen. Okay. I'll give you a moment to look at that. And let's move on to our next problem. All right, now we've got the same thing, different bases, and we'd like them to be the same base. One thing that you might remember is that 1/8 is the reciprocal of 8, so I could write it as 8 to the negative 1 power. So that's going to be a useful thing. And then I got to hope that 512 is a power of 8, right? So I know 8 to the second, that's 64. What's 8 to the third? Well, that's 64 times 8. Let's see what we get. 8 times 4 is 32. That's a good start. Carry the 3. 8 times 6 is 48. Plus 3 is 51. So 8 to the third is 512. So we can write these both as power of 8, which is really nice. So this is 8 to the negative 1 times negative 3a, or raised to the negative 3a, sorry, equals 8 to the third raised to the positive 3a. So here we're going to multiply again, so it's 8, and negative 1 times negative 3a is positive 3a, and 3 times 3a is 9a. Now we can ignore them and have 3a equals 9a. So how are we going to reconcile this issue? Well, let's start by getting all the a's on the same side. I might subtract 3a on both sides and have 0 equals 6a, and I'll divide by 6 on both sides and have 0 equals a. So a equals 0. And it's perfectly okay for us to come up with an answer like a equals 0, that it happens. All right, I'll give you a moment to look at that. And let's move on to our next problem. All right, this time we've got things that we need to solve, and we've got this multiplication problem equal to 5,000. It would be helpful if all of our bases were 5,000, and the only issue is this one. So I'm going to rewrite it as 5,000 to the negative 1 power raised to the negative 2z times 5,000 raised to the negative 2z plus 2 equals 5,000. And I'm going to think of that as being raised to the first power. So I need to do multiplication there. Raising powers to powers means multiply the powers. That's 5,000 raised to the positive 2z times 5,000 raised to the negative 2z plus 2 equals 5,000 raised to the 1 power. And then, when you've got like bases and you're multiplying, as we do in that situation right there, all we need to do is add the exponent. So this is 5,000 raised to the 2z plus negative 2z plus 2 equals 5,000 raised to the 1. And that's going to give us 5,000. I don't know why they keep giving you weird problems like this, but that's okay. 2z plus negative 2z is 0. 0 plus 2 is 2. And so we come up with another contradiction, because 5,000 squared can't possibly equal 5,000 to the first. So again, we get no solution. Otherwise, you would have ignored the bases and set the exponents equal to each other, and you would have had 2 equals 1. And if you would have had z's involved, you would have been solving for z, but they're more interested in showing you the no solutions. I'm not sure exactly why, but there we have it. I'll give you a moment to look at that. All right, and let's move on to our next problem. Now we've got 5 512, and 1 over 64 equals 512. And you might recall that 8 squared was 64. 8 to the third, 8 cubed was 512. We've already figured that out. So we can write everything in terms of 8, with a base of 8. So I can write this as 8 to the third raised to the x minus 2 over, this would be 1 over 8 squared, which would be 8 to the negative 2 raised to the 3x equals 8 to the third, right? So let's do the multiplication here. We're going to have to distribute, do the multiplication here. That's 8 to the 3x minus 6 over 8 to the negative 6x equals 8 to the third, and I'll have to keep doing it over here. Let me box this all just to make sure here. So then let me move this up to the top. When you have negative exponents in a fraction, what it's telling you is that you're on the wrong side of the fraction, and all you have to do, excuse me, to fix that is take the whole thing, move it to the top, and then lose the negative, or move it to the bottom and lose the negative, depending on what side of the fraction you're on. So this is 8 to the 3x minus 6 times 8 to the 6x equals 8 to the third. And now I can add exponents. So this is 8 to the 3x plus 6x minus 6 equals 8 to the third. And then we'll have 8 to the 9x minus 6 equals 8 to the third. And now I can finally ignore the bases and say 9x minus 6 equals 3 and solve that. If I add 6 to both sides, I get 9x equals 9, divide by 9, and I get x equals 1. All right. I'll give you a moment to look at that. All right, let's go to our next problem. And let's see how we might solve this one. So first of all, let's rewrite this. We've got 64 to the negative 3x minus 3 times, instead of just calling that 64, let's call it 64 to the first, okay? Plus 22 equals 38. So let's do some stuff here. First of all, let's get all our numbers, all our just regular numbers on one side, starting with that because I might want to put the base 64s together. I'll take a look at it again after I'm done with that little maneuver. But I'm trying to decide what's the easiest way to do this is why I'm waiting. Okay, so then 38 minus 22 is 16. Okay. So, yeah, let's put these two together now, add the bases, and that'll be 64 raised to the negative 3x minus 3 plus 1 is minus 2, right? Negative 3 plus 1 is negative 2, equals 16, and now I need same bases, right? Well, I can't use 8 again, even though 64 is a power of 8, 16 is not. However, let's look at 4. We know 4 squared is 16, and if you do the math, it turns out that 4 cubed is 64. So I can say this is 4 cubed to the negative 3x minus 2 equals 4 squared. And then I can do the multiplication. I have to distribute, so that'll be 9x minus 6 equals 4 to the second. Now I can ignore the bases and do negative 9x minus 6 equals 2. Add 6 to both sides and have negative 9x equals 8. Divide by negative 9 on both sides and have x equals negative 8 over 9. All right, I'll give you a moment to look at that. And we've got one more problem in this section, so let's take a look at that. All right, yet another one where we need to solve, and notice that we've got a plus 7 over here and a plus 7 over here. So let me rewrite this. And what we're going to do is we're going to start looking at the plus 7s first, because you always want to get rid of pluses and minuses first. Essentially, you want to go in reverse grouping order, which always means get rid of the farthest things away first, right? The things least grouped with it. So I'm going to subtract the 7 on both sides, and what's nice is it's going to cancel them on both, because 7 minus 7 is 0 in both cases, right? And then we've got 42 times 3 to the 2 minus 3a equals 14 times 3 to the negative 2a. And we still can't deal with all of that quite yet. So how are we going to deal with things? Well, let's get rid of the, say, the 14. We could have gotten rid of the 42. It doesn't really matter. 42 divided by 14 is 3, I believe. So this is 3, or 3 to the first, times 3 to the 2 minus 3a equals 3 to the negative 2a, and now we're really getting somewhere, right? Now we can add exponents and have 3 to the 1 plus 2, which is 3, minus 3a equals 3 to the negative 2a. And now I can ignore the bases, and let me continue it over here. 3 minus 3a equals negative 2a. I might add 3a to both sides and have 3 equals negative 2a plus 3a is 1a, or just a, and I'm done. So a equals 3. I'll give you a moment to look at that. And thank you so much for watching.